there's a lot of different ways that you can represent a linear equation. So for example, if you had the linear equation y is equal to 2x plus 3, that's one way to represent it. But I could represent this in an infinite number of ways. I could, let's see, I could subtract 2x from both sides. I could write this as negative 2x plus y is equal to 3. I could manipulate it in ways where I get it to, and I'm not going to do it right now, but this is another way of writing that same thing. Y minus 5 is equal to 2 times x minus 1. You could actually simplify this, and you could get either this equation here or that equation up on top. These are all equivalent. You can get from one to the other with logical algebraic operations. So there's an infinite number of ways to represent a given linear equation. But what I want to focus on in this video is this representation in particular, because this one is a very useful representation of a linear equation. And we'll see in future videos, this one and this one can also be useful depending on what you are looking for. But we're going to focus on this one. And this one right over here, it's often called slope-intercept form. Slope-intercept form. And hopefully in a few minutes, it will be obvious why it is called slope-intercept form. And before I explain that to you, let's just try to graph this thing. I'm going to try to graph it. I'm just going to plot some points here. So x, comma y. And I'm going to pick some x values where it's easy to calculate the y values. So maybe the easiest is if x is equal to 0. If x is equal to 0, then 2 times 0 is 0. That term goes away, and you're only left with this term right over here. Y is equal to 3. Y is equal to 3. And so if we were to plot this, actually let me start plotting it. So that is my y-axis. And let me do the x-axis. So that can be my x. Oh, that's not as straight as I would like it. So that looks pretty good. All right, that is my x-axis. And let me mark off some hash marks here. So this is x equals 1, x equals 2, x equals 3. This is y equals, let me do this, y equals 1, y equals 2, y equals 3. And obviously I can keep going, This would be y is equal to negative 1. This would be x is equal to negative 1, negative 2, negative 3. So on and so forth. So this point right over here, 0, 3, this is x is 0, y is 3. Well, the point that represents when x is equal to 0 and y equals 3, we're right on the y-axis. If they have a line going through it and this line contains this point, this is going to be the y-intercept. So one way to think about it, the reason why this is called slope-intercept form, is it's very easy to calculate the y-intercept. The y-intercept here is going to happen when it's written in this form. It's going to happen when x is equal to 0 and y is equal to 3. It's going to be this point right over here. So it's very easy to figure out the intercept, the y-intercept, from this form. Now you might be saying, oh, well, it says slope-intercept form. It must also be easy to figure out the slope from this form. And if you made that conclusion, you would be correct. And we're about to see that in a few seconds. So let's plot some more points here. And I'm just going to keep increasing x by 1. So if you increase x by 1, so we could write that our delta x, our change in x, delta Greek letter, this triangle's Greek letter delta represents change in. Change in x here is 1. We've just increased x by 1. What's going to be our corresponding change in y? What's going to be our change in y? So let's see. When x is equal to 1, you have 2 times 1 plus 3 is going to be 5. So our change in y is going to be 2. Let's do that again. Let's increase our x by 1. Change in x is equal to 1. So then if we're going to increase by 1, we're going to go from x equals 1 to x equals 2. Well, what's our corresponding change in y? Well, when x is equal to 2, 2 times 2 is 4 plus 3 is 7. Well, our change in y is equal to 2. We went from 5. When x went from 1 to 2, y went from 5 to 7. So for every 1 that we increase x, y is increasing by 2. So for this linear equation, our change in y over change in x is always going to be, our change in y is 2 when our change in x is 1, or it's equal to 2. Or we could say that our slope is equal to 2. And let's just graph this to make sure that we understand this. So when x equals 1, y is equal to 5. And actually, we're going to have to graph 5 up here. So when x is equal to 1, y is equal to, and actually this is a little bit higher. Let me clean this up a little bit. So this one, let me erase that a little bit, just like that. So that's y is equal to 4, and this is y is equal to 5. So when x is 1, y is equal to 5. So it's that point right over there. So our line is going to look, you only need 2 points to define a line. Our line is going to look like, let me do this in this color right over here. Our line is going to look like, something like, let me see if I can, I didn't draw it completely at scale, but it's going to look something like this. This is the line. This is the line. Y is equal to 2x plus 3. And we already figured out that its slope is equal to 2. When our change in x is 1, our change in y is 2. If our change in x was negative 1, our change in y is negative 2. And you could see that if from 0 we went down 1, if we went to negative 1, then what's our y going to be? 2 times negative 1 is negative 2 plus 3 is 1. So we see that the point 1, or the point negative 1 comma 1 is on the line as well. So the slope here, our change in y or change in x, if we're going from between any 2 points on this line, is always going to be 2. But where did you see 2 in this original equation? Well, you see the 2 right over here. And when you write something in slope-intercept form, where you explicitly solve for y is equal to some constant times x to the first power plus some other constant, the second one is going to be your intercept, your y-intercept, or it's going to be a way to figure out the y-intercept. The intercept itself is this point, the point at which the line intersects the y-axis. And then this 2 is going to represent your slope. And that makes sense, because every time you increase x by 1, you're going to multiply that by 2, so you're going to increase y by 2. So this is just a kind of a get your feet wet with the idea of slope-intercept form, but you'll see, at least for me, this is the easiest form for me to think about what the graph of something looks like. Because if you were given another linear equation, let's say y is equal to negative x plus 2. Well, immediately you say, okay, look, my y-intercept is going to be the point 0, 2. So I'm going to intersect the y-axis right at that point. And then I have a slope of, the coefficient here is really just negative 1. So I have a slope of negative 1. So as we increase x by 1, we're going to decrease y by 1. Increase x by 1, you're going to decrease y by 1. If you increase x by 2, you're going to decrease y by 2. And so our line is going to look something like this. Let me see if I can draw it relatively neatly. It's going to look something, I can do it a little bit better than that. It's my graph paper is hand drawn. It's not ideal, but I think you get the point. It's going to look something like that. So from slope-intercept form, very easy to figure out what the y-intercept is, and very easy to figure out the slope. The slope here is negative 1. That's this negative 1 right over here. And the y-intercept is the point 0, 2. Very easy to figure out, because essentially that gave you the information right there.